I would like to introduce today's presenter, Brent Nagel. He is an applications engineer at Applied Sim Technologies. So go ahead and take it away, Brent.
All right. Well, thank you, Hope. And let me get my screen here shared. All right. Again, thank you, Hope, and thank you for having me. And I'd like to take some time today to talk about right angle heads. Just a little bit of an intro. My name is Brent Nagel, like Hope said. I've been with Applied Sim for almost 25 years. So been around CAM programming quite a bit. At Applied Sim, we sell and support a couple of different CAM systems, primarily SurfCam, which I'll be showing a little bit today. And I guess we'll get started. So the agenda. So talk about kind of why use an angled head, the different types, talk a little bit about programming by getting into the different arc planes. Since your tool is not parallel to the z-axis, you're now your tool axis is perpendicular to the main spindle, so we need to make arcs in different planes. I'll talk about that. A little bit about some basics in CAM systems, and then post-processing, setting up the different offsets for the tools, and then get in a little bit of more advanced programming. So why use an angled head? Biggest thing is flexibility, and you can add capability to a 3-axis machine. So, and what that enables you to do is eliminate some repositioning on the part, so you can complete multiple operations in one setup. Now you may run into, like anything new, you may run into some initial challenges, but I think the benefits outweigh those. So different types of angled heads. So main, kind of narrowing it down to two basic ones. You've got a fixed and adjustable. So the fixed would be, either pointing along the x-axis or y-axis. Actually, this one here looks like it indexes in between those degrees as well. But mainly, most people use them for, coming into the right side or along the x-axis, or the front or back using the y. And there's also adjustable, or some people call it universal. So you can also get the kind of an angle of inclination in there too. And you also have different other different types, like the the slim type on the far left, so you can get into some tight areas. Can have them extended. So again, if you have a taller part and you need to get on the side of it, you can use the a more of extended model. And then you also have a double-ended one. So if you're on the inside of a part and you wanted to, utilize both directions, you can have a double-ended right angle head as well. Some other different types, you've got some they call build-up types, so you can adapt for some quicker tool changes. You can see here you got multiple different tools that can fit into that same right angle head, allow for quicker tool changes, and again, better utilization. You also have a modular type. So if you've got different machine tools in your building that handle different holder types, you can get a right angle head that would fit each of those holder types as well. So it's very interchangeable. Other options are coolant. So you can just run like a flood coolant through the pin. You can also have it go through the pin and the spindle, or all the way through the shank. If you have some through, if you have the through coolant option on your machine, you could do that as well with your right angle head. And then talking about coolant, most of these that I've talked about, these last few of them here, are gear driven. So when the spindle turns, turns a gear, and that turns a right angle head. There's also an option for a coolant driven one, so you can get a kind of a much smaller area. Again, your horsepower is going to go down, but if you need to maybe deburr an internal hole or something, a coolant driven right angle head may be a better fit. Going to get into a little bit of programming. So the biggest things with right angle head are the 3 different ordinate planes. So you got a G17, which is what most people are used to. If you're milling along the X and Y axis, a G2 or G3 is going to be parallel to the X and Y axis. You also have 2 more coordinate planes, the G18 and G19 plane. So your 18 plane is going to be along the XZ. So if you think of kind of standing here, it says circular motion looking from the rear of the machine towards the front. So it's, G2 is considered clockwise, and you can see that clockwise rotation if you're kind of standing behind the machine and looking at it. And then with the G19 plane, so you're kind of looking across the machine in the YZ plane. So your G2s and G3s are going to be parallel to that YZ plane. So your coordinate planes, your G8, 17, 18, and 19, most of the time you think of them as for programming arcs. Well, it also determines on some machines, like on the Haas machine, it determines your drilling axis. So in this case, an example I've got here of what I call an X plus drilling, so that angled head is facing to the right or in the X plus direction. So there I'm going to be in the G19 plane. You kind of see in the can cycle area. So I got G19, so it's doing a PEC cycle at G83, and I'm going to a full depth of X of 0.5, and then with a PEC amount of 0.1. So it's going to drill along the X-axis in a positive direction. So that G19 plane kind of tells the machine, it's going to drill along the X-axis, so it looks at the X value along that can cycle line to figure out the depth. And again, that would be the same for the G18 plane. You're on the XZ axis, and it's going to drill along the Y axis. And some programming notes, I guess. One thing you have to be aware of is on most gear-driven right angle heads, when you're spinning the spindle clockwise, it turns the gear and actually reverses the direction at the cutting point. So an M3 would be counterclockwise, and then an M4 would be clockwise. So when you're programming a right angle head, you may have to, adjust your M3 and M4 to give you that right, the correct spindle direction. And you can have the post do that for you too, which we'll talk about in a little bit. So construction views. So in most CAM systems, you have, either a C view, construction view, or some systems call it a CPL, or, WPL for work coordinate plane. And most of those are in what they call local coordinate space. So, like for, say, if you have an indexer, for instance, you're going to have a new view for that particular index, and it's going to output in G17, X and Y. But in our case, what we need to do is, we need that post to output the numbers from the machine coordinate, or from that world coordinate view. So just some things to keep in mind when you're programming in a CAM system. And talk about post processors a little bit, and just kind of on the CAM support side of things, which is what I do, kind of break it down into kind of 3 different levels of post processing. So I've got some simple posts. So, if you get a right angle head for a specific part, or, specific project, and you're only going to be programming it from, say, the X positive direction. Well, in that case, it's a pretty simple post. and you would have basically a separate post just for that right angle head. Separate post for each orientation. So you got X, like an X positive, X negative, Y positive, Y negative, and then you would post that out and kind of merge it into a program that you currently have if you're doing other operations. Kind of the second level would be a more integrated one, where you could set up multiple orientations in a single post. So in that case, you would have one post for everything, and then if it came across a right angle head, it would change your coordinate plane, or not coordinate plane, your work plane, like your G17 or G18 or G19, and output it without having to cut and paste. Like in that first example would be a more simple one where you got to cut and paste, where an integrated one is kind of a one button push and you're done. And then the kind of a third level would be a more advanced. So if you had say a universal or adjustable type, it kind of adds a little bit more complexity to the post. And then some questions that your post developer might ask is, can the machine use CAN cycles in the G18 or G19 plane? A lot of machines, if you cannot do that, then you need to output kind of a point-to-point method. So rather than using a CAN cycle like a G81 or 83 or 73 or whatever, you would need to do a point-to-point, and the post developer would need to know how to do that. Another one is if your machine can utilize what they call vector tapping, like on a Haas that's a G184 or 174, which is essentially it's you have a start position and an end position, and your machine's going to utilize a tap cycle along that. So it's going to go turn the spindle one way going in and then reverse it coming out. And also if your machine can utilize cutter comp in that G18 or G19 plane. All right, and so setting up your tool. Typically for a length offset, on a straight vertical tool is just a G73, or I'm sorry, G43. You're setting to on a normal 3-axis, you'd be setting it to the tip of the tool. In this case here, for a right angle head, you'd be setting it to the edge of that tool, and then adjust the radius for that. So in this case, your Z would be along the center of that tool. Now you could use if you have a tool setter probe on your machine, but just be aware that you may need to adjust a macro, because the center of the spindle is no longer in the center of that setter probe, so you got to adjust it for the right angle head. So it's setting kind of the Z for the tool, and then for the X and Y offset, typically you're going to have a different work offset for each right angle head. So if I'm using a G54 for the bulk of my program, and then for the right angle head, maybe I might use G55. So I'm in a different work coordinate to adjust for that X and Y offset of the right angle head. And if you use multiple tools in your angled head, you could set a register or variable in your machine for the stick out length, and then you'd utilize a macro for adjusting for that. It all depends on what you're going to use your right angle head for, and if you have multiple tools, and how often. So the more time spent up front, the more time you're going to save down the line if you're utilizing multiple tools in that regard. Some more advanced programming end of it, just some pointers. If you have a tool presetter, an offline tool presetter, it's recommended if you have your like a universal tool, or an adjustable angle tool to use your presetter to help setting that. Even with a standard, tool along, say, the x-axis, a standard right angle head, not even a at a compound angle, a presetter is useful for that, just to give you an accurate measurement. And I've also seen, and I've got an example of one for a macro for if you're drilling at a compound angle. So in the macro, you can set what your angle along the X and Y, and also your angle along the Z, and tell it if you're drilling, tapping, or peck drilling along that. So you could use that for a custom drill cycle. So if you've got a maybe a deep hole or something, you can utilize a macro to give you a especially if you're at a different angle and you can't use a can cycle, you could use a macro to give you kind of an emulated peck cycle for that. So so with that, kind of jump into CAM system and kind of give you the basics of how I would go about programming. So I've got a pretty simple part here. So here got kind of just a rectangular block, and I've got some points and also a contour along the right side. So that would be along the the YZ plane of that. So first thing I would do is change my construction view to that right side. So you can kind of watch my C view here. When I change that, my Z axis is now going to be pointing along that, which is required if I want the tool to go along that Z axis. So then I would go to NC 2 axis, and depending on what operation I want to do, I'm just going to do a contour, and we'll chain that piece there. So I've got a 1/2 inch end mill, change my tool number, and we'll go to cut control, and we'll just do, maybe I'll go 200 thousandths deep, and I've got an arc lead in and an arc lead out on that. So go ahead and pick OK. It's asking me what side I want to contour. I'm just going to pick the inside. So there I have a tool path that's going to go from that right side, and if I back plot it, you can see that it's coming in from that side there. So what I have set up is a just a single post for this is a Haas, and I've got X negative. So the tool actually is pointing towards the X negative. So we'll go ahead and hit post on that, and sorry, it came up on my other screen, and kind of go through this a little bit. So so it's setting my G43, and it automatically put in my M4. So it's spinning the spindle clockwise. Actually, the main spindle is counterclockwise, so my right angle head tool is going to be spinning clockwise. And the G19, and it's giving me a a G3 with a J and a K. Well, if I do a quick back plot on that, I can see with this particular editor, I can see the tool path. Let me jump to a ISO view. It steps through the program, so I can get a good idea of what that tool path is going to look like before I send it to the machine. And then if I want to do some drilling, just do, again, I'm still in construction view 5, so I'm telling it what direction to come in from. And I'll just do a hole process, and I'll do all the holes. And I think I've got a cycle set up, so I can just adjust my depths if I need to. We'll go maybe 1/2 inch deep for that. Well, we'll go 1 inch deep, and then we'll tap. We'll go maybe 750 deep. So go ahead and pick OK. Yeah, a little deeper than expected. That's why. Yep. And if I go on again, I can post that out. So I've got my M4 spindle and then G81, and also I have it set up in the post so when I'm tapping, I'm going to be tapping using a left-handed tap because my main spindle rotation is going to be opposite of the rotation at the tool. So that's using a kind of a single tool, single setup. So I have I'm only coming in from the right hand side with my right angle head, so I kind of have a one post for that. But if I had a part that started or that's utilizing or that has pieces on or features on different sides of the part, like in this one here, if I did a quick show a toolpath, I've got toolpath kind of on all four sides of it. So what I can do there is if I have a post that's set up for that, in this case here, I've got one that this one here, if I post that out, so I've got some machining on the top view. Might be easier just to see the back plot of it. So I was machining on the top, just doing a chamfer, and then machining on the different sides. So if I pause that and look back in the program, my post is automatically adjusting. In this case here, it's going to the G19 plane. Then it's machining from the on the left. So there's G19 and there's machining on the back side. So it's a G18. So it all depends on on your level of what your requirements are. If you're going to be programming from different sides, get the post that's going to help you utilize that. So, so just a couple of quick examples on the abilities of the post processors. And see, the last one I wanted to show you here is I've got a macro that will allow you to, in this case here, it's for a Fanuc type machine. So here's a G65 line, and it's got a number of different variables there. And in the macro, you've got your what they call the your B axis kind of rotating about Y, and your C axis rotating about Z. So what you can do is again, here I'm going from, 10 degrees on B and 45 in C, and I'm doing a, see, the A2 is the type. So on the type here, a number 1 would be just a G81, or sorry, G81 would be 0, G82 would be 1, G73, which is a chip break, would be 2, a PEC would be 3, and a tap and ream would be 4 and 5. So in this case here, I'm doing a G73, and then I've got some PEC amounts and some incremental clearance amounts. Easier just to show it in a back plot and what you'd be able to do with something like that. So nice thing about the editor here is it'll calculate the in this case here we're using macros for different variables. So you can see it's kind of bouncing back and forth between those. So it's doing an incremental chip break on that. So so it's at a compound angle. So if I look at this from an XY view or a XZ view, you can see it's at a different angle, kind of a compound angle. So and you could do that in a CAM system too. But if you have a kind of a one-off that you wanted to do, so you got use of macros in that as well. So and I can make this macro available.
We do have a couple questions. Brent, how do you get the length of the tool for X-axis?
Okay, so if it's a right angle head that is along the X-axis, so what you typically do is position the tool to like the edge of a wall or something, and just like you would set up a work offset for a normal vertical tool, you would index that tool in and then set it for a different work offset that you're using. So let's say G54 for the whole program, and for the right angle tool, you would use say G55. So the actual X and Y values of that work offset would, or I'm sorry, the Y and Z values for that work offset would be the same, but the X would be offset for the length of that tool.
Our next question is, can the universal head macro program be sent to the participants?
Yes, I could make that available however you want. If we want to email it to them or make a link to download it, that would be fine with me.
Okay, great. Thank you. All right, well, we thank you again for joining us today. And until next time, stay safe, stay healthy, and thank you for your business. Have a great day.